You were not designed to age this fast. Not biologically, not evolutionarily. Inside your body, at this exact moment, trillions of cells are performing microscopic maintenance. Proteins are folded into precise three-dimensional shapes. DNA strands are scanned continuously, and when damage appears, repair enzymes move in. Damaged mitochondria are dismantled and recycled. Immune cells patrol your tissues quietly, eliminating threats long before you notice symptoms. There is an entire internal civilization working in silence. Organized, adaptive, ancient. And yet, something doesn't align. Metabolic disease is rising across developed societies. Chronic inflammation has become common. Energy levels fluctuate unpredictably. Recovery feels slower. Mental clarity feels fragile. Despite unprecedented comfort, many people feel biologically vulnerable. If the human body evolved with repair systems refined over millions of years, why does deterioration feel so predictable? What if aging, as we experience it today, is not simply about time passing, but about repair systems that are no longer being fully activated? Aging is not a programmed shutdown. It is the accumulation of cellular damage combined with insufficient repair. Damage is inevitable. Repair is conditional. And the balance between the two determines how fast biological aging unfolds. In youth, repair systems operate aggressively. Stem cells are highly active. Hormonal signals promote regeneration. Inflammatory responses resolve quickly. Recovery is faster. Resilience is stronger. But with time, these systems begin to slow. Not because they disappear, but because their activation becomes less frequent. Here is the critical insight. Repair systems are not governed only by chronological age. They are governed by signals. Biological signals, metabolic signals, environmental signals. In 2016, Japanese scientist Yoshinori Ohsumi received the Nobel Prize for his research on autophagy. Autophagy literally means self-eating. Despite the dramatic name, it is one of the most elegant renewal systems in biology. Inside each cell, damaged proteins and dysfunctional components accumulate over time. Autophagy identifies those elements, encloses them, breaks them down, and recycles the raw materials into new structures. It is cellular housekeeping. Without it, debris accumulates, mitochondria lose efficiency, inflammatory signals rise, cellular communication weakens. Impaired autophagy has been associated with neurodegenerative disease, metabolic dysfunction, cardiovascular decline, and accelerated biological aging. But autophagy is not permanently active at full intensity. It is triggered. And one of its most powerful triggers is temporary nutrient scarcity. When food intake drops, insulin levels decrease. As insulin falls, a molecular pathway known as mTOR becomes less active. mTOR regulates growth. When it is highly active, the body prioritizes building. When its activity decreases, the body shifts toward maintenance. Growth builds, maintenance repairs. For most of human history, food availability fluctuated. Periods of abundance were followed by periods of scarcity. These cycles were not intentional. They were environmental realities. Under those conditions, repair systems like autophagy were activated regularly. Cells were forced to clean and recycle. Energy had to be used efficiently. Modern life has largely removed that fluctuation. Food is available at all hours. Snacking reduces metabolic gaps. Caloric intake rarely drops significantly. From a signaling perspective, the body perceives continuous abundance. When abundance is constant, mTOR remains more active. And when mTOR remains elevated, autophagy becomes less frequent. Cells spend more time building and storing, less time cleaning and repairing. Over months and years, that imbalance can influence resilience. Not dramatically, incrementally. Small deviations accumulate. Mitochondria may become less efficient. Energy output per unit oxygen can decline. Insulin sensitivity may gradually weaken. This gradual shift often manifests as low-grade chronic inflammation. Inflammation in short bursts is protective. It eliminates pathogens. It repairs damaged tissue. It coordinates immune defense. But when inflammation becomes persistent, even at low levels, it alters cellular communication. Oxidative stress increases. Gene expression patterns begin to shift. The change is subtle, often invisible at first. If repair processes are activated less frequently, while inflammatory signals remain slightly elevated, the balance tilts. Not suddenly, but steadily. Repair is metabolically expensive. It requires energy. It requires resources. It requires biological urgency. The body allocates energy strategically. When the environment signals stability and constant abundance, energy is directed toward growth and storage. When the environment signals challenge or scarcity, energy shifts toward maintenance and resilience. The body responds precisely to the signals it receives most often. It adapts to patterns, not intentions. And today, the dominant signals are stability, predictability, continuous availability. From a comfort perspective, this represents extraordinary progress. From a biological signaling perspective, it represents unprecedented uniformity. The human body evolved under variation. Temperature changed. Food supply fluctuated. Movement was required for survival. Environmental pressure was constant, and that pressure activated repair pathways again and again. Variation demands adaptation. Adaptation activates resilience. This principle is known as hormesis. Small, manageable stress stimulates protective biological responses. Exercise damages muscle fibers. Recovery builds them stronger. Cold exposure challenges circulation. Heat exposure stimulates protective proteins that stabilize cellular structure. Short-term stress enhances resilience. Long-term, uncontrolled stress weakens it. Your ancestors experienced physical stress regularly. They walked long distances. They carried weight. They adapted to seasonal shifts. Today, physical stress has decreased dramatically, yet psychological stress has increased. Chronic psychological stress elevates cortisol, disrupts sleep, alters metabolic signaling. But it does not necessarily activate the same adaptive repair mechanisms. The body adapts to what it experiences most often, and what it experiences today is comfort with low variation. The body responds to cues. It always has. If the signals suggest constant safety, deep repair may not be prioritized. Your genes evolved in dynamic environments. Static abundance is evolutionarily new. The repair systems remain intact. They have not disappeared. They are conditional. They activate when demanded, when variation appears, when scarcity interrupts abundance, when movement challenges comfort. Perhaps aging is not only the passage of time. Perhaps it is the accumulated underactivation of renewal pathways. Inside you are survival programs older than civilization, older than agriculture, older than cities. They respond to variation. They respond to challenge. They respond to necessity. The question is not whether your body can repair itself. It can. The question is whether modern life has made repair feel unnecessary. And if repair intensifies only when survival seems uncertain, what does endless comfort communicate to a body shaped by challenge?